Alright, we're doing probability. So what is probability? Well, probability is the likelihood of something happening. How is it represented? Well, it's often represented on a bell curve. And what you're looking for is probability of something being inside the shaded region, or the area of the shaded region. Alright, so what does this represent? Well, this represents the probability of your random variable, or x, being between either a or b, or your lower bound and upper bound. P of x. Well, P of x is your probability density function. It's often written like this. And it must satisfy two important conditions. The first being that P of x cannot be 0 or lower than 0, so it can't be negative. The second one is that you're to assume that x is actually inside of an interval. The interval itself the function of the interval must actually equal 1. Therefore, you can assume that the x will be inside there, and you can solve for it.
One of the examples we're going to do, we're going to let P of x, which is our density function, is going to be c sine of x, which c is some constant greater than 0. And to find a constant, we have to take the domain that our probability density function is iterated over and plug that into our probability density function, which looks like the integral from your lower limit, which is 0, and your upper limit, which is pi. And you're going to have c, but since c is a constant, we can pull that outside. We can write sine of x on the inside here, dx. With this, you just do the integral of it. So you have c, parenthesis, negative cosine of x, integrated from 0 to pi. And working this out, you have c, parenthesis, negative cosine pi, which is negative 1, which is positive, minus cosine of 0, which is negative 1. We're taking the negative in. So this makes this positive. So it's 1 plus 1. So c times 2 is what we get here. But we have to make this equal to 1 because of the normalization condition. We have to assume that this integral with the constant over our domain equals 1 from 0% to 100%. So that's why we equal it 1 here. So our c, our constant, equals 1/2. And once we have our c, we have our p of x is equal to 1/2 sine of x. So since we have our p with our constant that we found, we can plug this into our probability function up here, which the probability of our random variable from a to b is equal to the integral from a to b of p of x dx. So if we work that out over here, we have our integral from our lower limit, which is pi over 4, and our upper limit, which is 3 pi over 4. And then we plug in our p of x, which is 1/2 sine of x dx. And since 1/2 is a constant, we can pull that out of the integral. So we're left with the integral of sine of x dx from pi over 4 to 3 pi over 4. So if we iterate this into the anti, we get 1/2 times negative cosine of x, iterated from pi over 4 to 3 pi over 4. And this comes out to 1/2 of negative cosine of 3 pi over 4 is negative square root of 2 over 2 minus, and then cosine of pi over 4 is square root of 2 over 2. So if we take all of these negative and minuses, we get positive square root of 2 plus square root of 2 over 2. So we get 1/2 times square root of 2, which our final answer is square root of 2 over 2. So that means our probability of our p of x, which is our random variable, being between pi over 4 and 3 pi over 4, is somewhere in the range of 71%.
Actually, here's another problem. The question is P a probability density function on negative pi over 2 to pi, given the function is cosine of x, where it does satisfy the normalization condition, meaning the function does equal 1 when you find it. But it does not satisfy both conditions, therefore it cannot be a probability density function, because you have a as a negative. And as we remember, you can't have a negative number as one of your boundaries.
So to not go the math route and instead use application, one example I'm going to go over is how probability is used in finding where an electron is in the outer shell of an atom. So in atoms, there are different states, the first being the ground state, and then increasing in energy as you go further out. So if you think about it, it's kind of like the circle with the nucleus, with electrons that are slowly get further away from it. However, as you get further away, the probability decreases. So in order to find how often the electron is between the first state and the atom to find the ground state is using this equation. So I don't know if you guys can see, but it's P of R equals 4A initial, also known as Bohr's radius, to the negative third times E to the negative 2R divided by A initial times R squared. So how we would use this to plug it in, similar to how we have in the past with the other examples, is we would have our probability function equal P of 0 is less than or equal to R, which is less than or equal to A initial. So that's how you would apply it here, and then you would set this equal to the integral of P of R from our B, which is A of 0, and 0. So using this is how one way we can apply probability. So what this brings us to, what the whole point of this is how we can apply it. So some examples of how we can apply it are in stats, finding distribution under the curve, as we showed earlier, data analytics, coding, and statistical analysis. These are all kind of things that go into things such as like research and in the field, making sure your work is comparable to other people's, as well as accurate. And this allows us to then, make discoveries, use in health data and safety, making sure like people are using things with knowledge and aware. And yeah, these are just a few of many different ways that probability allows us to understand the world around us.